Alright, so the opposite of doubling something is cutting it in half, and that means we have a series of not only double angle identities, but also, as the title says, half angle identities. So how do you use those? Well, first of all, you have a list of two different forms, and I'm going to show you how to use this side right here, because this is the side that you customarily end up using, or the easier side. These are just alternate forms that you can get by squaring all the identities on the left. We'll stick with the ones that I boxed off. So our strategy is very similar to the double angle identities. We have to pick the right identity. So on number, and this is not hard to pick, on number 1, or on number 3 I should say, the first one, obviously the identity we're going to be using is this one. So we have plus or minus, and then the key thing is I want to show you how to decide if it's plus or minus, because that is often what tricks people out. So actually this square root is supposed to be covering the entire thing. So our first step is we're going to pick whether it's plus or minus. How do we know? We're dealing with theta over 2. Okay, so they're telling us that theta is between 540 and 630. That means theta over 2, I just have to cut those in half. So half of 540 is 270. Half of 630 is 315. So if I just draw a picture right here, 270 is right here in this green part, and 315 is somewhere about there. So that means we're right here with this angle, we are in the fourth quadrant. Okay, theta over 2 is in the fourth quadrant. Theta is between 540 and 630. So I'm going to show you where that is. Theta is right here. 540, if we subtract 360 from that, we would get 180. If we subtract 360 from this, we would get 270. So in purple, I'm going to mark where theta is. Okay, theta is in this quadrant, and that's quadrant 3. 3Q stands for third quadrant. But theta over 2 is in the fourth, so I don't want to confuse you. Obviously, if you take an angle and then you cut it in half, that's probably going to move you in many cases to a different quadrant. If I have 100 degrees, that puts me in the second quadrant. If I cut it in half, that's 50. 50 is in the first quadrant. So we have to keep track of both of these things. This plus or minus right here refers to where theta over 2 is. We said that we're in the fourth quadrant. What is sine in the fourth quadrant? Okay, and that's this part right here. Use ASTC. We have to do this twice. If we're in the fourth quadrant, cosine is positive, but that means sine is negative. So we're going to have a negative in front of the square root. Okay, now the formula says 1 minus cosine of theta. So 1 minus cosine, and then cosine of theta is going to be, well, we don't know what that is yet. We're going to find that. Okay, so let me rewrite this right here. Okay, and then obviously our second part of our strategy, part B, says find whatever part of the identity you're missing, and that is where that's why I put these Pythagorean identities here. We're missing cosine because in all of these formulas have a cosine in them, so if that's the one thing that we need to find on every one of these formulas is to find out what cosine is. So let me rewrite this. We have sine theta over 2 equals negative. Why negative? Because we're in the fourth quadrant. Okay. And then negative of 1 minus, and then let's find out what cosine is by using this. We know that sine is negative 4 over 5, so we can use our identity to find out what cosine is. And this is something we did early on in this chapter, in this section. So negative 4 over 5 squared, and that's going to be 16 over 25 plus cosine squared equals 1 is the same as 25 over 25. And the reason I'm doing that is because I know that we're going to have to subtract from both sides. Alright, and then here is what we do next. We're going to subtract 16 over 25 from both sides. Subtract 16 over 25. So 25 minus 16 is 9 over 25. Cos squared is going to be that, and when we square root both sides, we will put a plus or minus in front of this. So that means cosine is equal to square root of 9 is 3, square root of 25 is 5, plus or minus. So how do we decide if it's plus or minus? And the answer is we do it based on this. We just found out that cosine, I'm going to rewrite it, cosine is equal to positive or negative 3 over 5. How do we decide? We decided up here at the beginning of the problem, we figured out that we were in the third quadrant. Okay, what is cosine in the third quadrant? Third quadrant is right here. Cosine is negative in that quadrant, so we're going to take the negative 3 over 5. So what you have to do is where you see cosine of theta, I'm going to simply replace that with negative 3 over 5. That's what this means right here. Plug it in just means literally find out what cosine is. We found it, and then we plug that in. Now all we have to do is simplify this. And by the way, part D says you use ASTC. You can kind of mix these steps around in terms of the order that you do them. We actually did this as our very first step. Okay, so we found out that This one, theta over 2, was negative. This right here is based on what theta is, and theta is in the third quadrant. Okay, so we pretty much have the answer. Now all we have to do is just simplify this out. Okay, so here's what we have. Let me bracket this off here. We have negative square root minus a negative is like plus, so this is 1 plus 3/5 over 2. And then we have negative, what's 1 as a fraction? Okay, and the answer is 1 is the same as 5 over 5. So I'm going to rewrite this as 5 over 5 plus 3 over 5. That's still all over 2. Okay, then we have 5 over 5 plus 3 over 5 is 8 over 5. And then 8 over 5 divided by 2. Dividing by 2 is like multiplying by the reciprocal of 2, which is 1 over 2. That and that will cancel. This becomes a 4. So we're left with negative square root of 4 over 5. And we could simplify that to negative square root of 4 is 2, and then root 5 is just root 5. Now that's not wrong the way that we have it, but it's customary to not leave any roots in the bottom. So to get around that, we can multiply the top and the bottom by square root of 5. And why is that? Because square root 5 times square root 5 is just 5. And the top becomes negative 2 root 5 over 5. That's our answer right there for that problem. Okay. So that was sine of theta over 2. There is a way actually to check this on the calculator. Okay, and I'll show you how to do that right now. Alright, so here's how we can do this. So we know at the beginning that sine of theta was negative 4 over 5. Let's figure out what that angle was. Let's do inverse sine of negative 4, and then I'm going to move it over so you can see it. Negative 4 divided by 5. Let's figure out what angle that was. Okay, so that tells us that theta, and actually I believe I'm in radians and I want to be in degrees here. So let's fix that. We'll go down to degrees, change that. Okay, now it should work. Alright, and now when we do, we get negative 53 degrees, and that's the same as positive, let's just subtract it this way, 53.13. That's the same as positive 306 degrees. So we know that theta is about 307 degrees. So that means theta over 2, all we have to do to get that is just divide by 2. We'll divide by 2, and that's 153. Let's take the sine of that angle right there. Take the sine of that angle, and sorry, my screen's freezing up here, so I'll just do it on a regular calculator. When we do the sine of that angle right there, we end up getting 0.45 approximately, 0.45. So how does that tie into our answer? Okay, well, if you look at what our actual answer was to this question right here, we ended up getting negative 2 root 5 over 5. So if you put that in a calculator, which I am doing off screen, but it turns out to be, and actually just one clarification, because my calculator is getting up. When we put this in a calculator, we got theta, you saw that on the screen, we got negative 53, I believe it was negative 53 point, maybe 1 degree. Okay, negative 53.1 degrees. But we know that theta is somewhere in this zone. It's between 540 and 630. So 540 puts us at 180 degrees, and 630 is the same as this right here. So between 180 and 270, so we have a reference angle of 53 degrees right there. Okay, 53 degrees, well that's the same as if you went to 540, that's all the way around plus another 180. If you add another 53 to that, 540 plus 53, you would get 593 degrees. That's actually what theta is. Okay, theta is 593. So theta over 2 means take 593, divide it by 2. Okay, that turns out to be 296.5 degrees. If you take the sine of that angle, you will get that answer that we got. You will get negative 2 root 5 over 5. So that's one way that you can check it. Alright, so I encourage you, if you haven't tried already, to pause the video and see if you can do the tangent example, which is number 4. Just going to clear that off. Alright, so here's how we would do tangent. It's very similar, same type of formula right there. We'll use this one right here. Okay, and then we'll fill this in. So first of all, plus or minus, they're telling us theta is between 180 and 270. So that is where I'm marking in red. So that means theta is in quadrant 3. Theta over 2, we divide that by 2. Theta over 2, this one divided by 2 is 90, and the other one divided by 2 is 135. So theta over 2 is between here and here. That's in quadrant 2. Okay, so how do we decide what tangent's going to be? Well, tangent, this plus or minus is based on where theta over 2 is. And we just said theta over 2, they're telling us here it's in quadrant 2. Tangent is negative there, so I'm going to put a negative in front. Okay, then for cosine, we'll fill this in just a second. I'm going to leave the minus cosine part alone for now. Now let's use this identity, okay, because we need to find, remember for all of these problems we have to find out what cosine is. Why am I using the secant one? Because secant and cosine are closely related. You just have to flip cosine over. So tangent is 4 over 3, so 4 over 3 squared is 16 over 9. That's the same as 9 over 9. When we add those, we get 25 over 9, which is sec squared. Okay, so now if we square root both of those, if we square root both sides, we're going to get plus or minus, let me just write this, we'll get plus or minus square root of that is 5 over 3. So that's what secant equals. So now the question is, what is cosine? Cosine is the reverse of that, so it's plus or minus 3 over 5. How do we know if it's plus or minus? Because we said that theta is in quadrant 3, and it's going to be minus because cosine is minus there. So we have minus 1 minus cosine, 1 minus negative 3 over 5, 1 plus negative 3 over 5. Those are our two results, so now we just have to simplify these fractions. Alright, so how do we do that? Well, we kind of actually did something very similar in the previous problem. We said this turned out to be 8/5. That was the exact same as the prior problem. 1 minus 3/5 is the same as 2/5. And then we can copy, there's still a negative there. 8 over 5 times reciprocal of 2 over 5 is 5 over 2. The 5's will cancel. That becomes a 4, that becomes a 1. So we have negative square root of 4, and that's the same as negative, no more square root, negative 2 would be our final result right there. So there is our solution.